Hey everyone, today we're going to take a look at Week 8, Lesson 2. Week 8, Lesson 2. This lesson is teaching us how to simplify radicals. I'm going to dive into a couple examples of how we want to simplify this and then work backwards to identify the step-by-step instructions. So if we're looking at your worksheet for Week 8, Lesson 2, problem number 1 says, what is the square root of 48? To simplify it. So there's many things that we can do to figure out this answer. In previous lessons, we've learned how to estimate the square root of 48. Using our perfect squares, we can see that the square root of 36 is 6, and the square root of 49 is 7. And so thinking about it as a number line, we can see that the square root of 48 would be a number somewhere between 6 and 7. That would be if we estimated it. We can also think about using our calculator to solve this. You can take your calculator and type in 48 and then hit the square root button. And you can see that our final answer would be 6.93, which does in fact fall between 6 and 7, much closer to 7. I'm going to go ahead and write that down because I think it will be helpful for us in a little bit. That if I were going to estimate or round, the square root of 48 is 6.93 or 6.9. And that's using a calculator. But sometimes when these get larger, we're not going to always want to use the decimal value of it. Sometimes it is easier to simplify and reduce the numbers so that we can work with the whole equation a bit more effectively. But for now, we're just going to learn how do we simplify this radical. What I'm going to do first to simplify is figure out what perfect squares can go evenly into this radical. And we like to work with perfect squares because perfect squares end up as integers, nice, pretty, even whole numbers with no decimals and no fractions. When we go throughout this lesson, every single number is divisible by 1. So dividing something by 1 doesn't help us simplify because it doesn't change the original value. 48 divided by 1 is still going to be 48. But we can see that 4 is a number smaller than 48. 9 is a number smaller than 48. 16, 25, and 36 are all numbers smaller than 48. So we're going to take a look at those numbers and decide, is 48 divisible by any of these perfect squares? And if you know right away and just want to dive in and start, that's great. If you're not sure, it is always going to work to just start with the largest number and work your way down. So a calculator is really helpful for this unit. We can do 48 divided by 36. Well, that gave us 1.33. That's not a whole number, so we move on. My next number is going to be 25. So let's try 48 divided by 25. And we get 1.92. Well, that's also not a whole number. So 48 is not divisible by 25. Our next number is going to be 16. So we'll write 48 divided by 16 and see if we get a whole number. 48 divided by 16. And we get 3. I have a weird setting on my calculator that says 3.00, but it is in fact 3. So I now know that the largest perfect square that fits evenly inside of 48 is 16. So we have the square root of 48. Well, I now know that I can multiply the number 16 times 3 to get to 48. So you see I have the square root of 48, which I can also write as the square root of 16 times 3. 16 times 3 is 48. So these are now equivalent expressions. They mean the exact same thing, even though they're written differently. And so I can write the square root of 48 as the square root of 16 times 3. But that also means I can write the square root of 16 times the square root of 3. If I multiplied the square root of 16 times the square root of 3, I would get right back up to the square root of 48. So once again, these are now 3 different equivalent expressions. Square root of 48 is the exact same as the square root of 16 times 3, which is the exact same as the square root of 16 times the square root of 3. Now we can think about this as, how do I simplify this? Well, we know from our first step that what we did is found a perfect square that fit evenly inside of 48, or that 48 was divisible by, and we chose 16. 16, the square root of 16 is 4. It's an integer, it's a nice, pretty even whole number. So I now know that the square root of 16 is 4. It comes outside of the radical because it's a whole number. This is a mathematical fact. The square root of 16 is 4. But the square root of 3 is not a perfect square. If we look at our list, we have 1, and then it jumps up to 4. So 3 can't be simplified any further, so we just rewrite it. We just bring it down, and it stays inside the radical. And so our final answer, or our most simplified version of the square root of 48, would be 4 root 3. And now let's bring it back to where we were earlier, where we put in the square root of 48 in the calculator and we got 6.93. But I can also type in the square root of 3 times 4. So I did the square root of 3 times 4, and I got 6.93. And my final answer, my most simplified radical, gave me the exact same decimal value as if I had typed the square root of 48 in the calculator. This is a way to verify and check whether or not your answer is correct. So let's go ahead and figure out what are the steps. What steps did we do to solve this? Well, the first thing that we did was identified a perfect square that the number is divisible by. So what is the largest perfect square that the radical is divisible by? That would be our first question. Write out the factors underneath a radical sign. So just like this, we had the square root of 48. Our first step was to identify the perfect square that the radical is divisible by, which was 16. And so step 2 is to write out those factors underneath the radical. That's 16 times 3. If you're comfortable, you can kind of blend steps 2 and 3, but 3 is to separate all numbers underneath different radical signs. And that's referring to this step here, where we took the square root of 16 times 3, and we put it into the square root of 16 times the square root of 3. Step 4 is to reduce your perfect squares. Reduce or solve. So reduce or solve your perfect squares is referring to right here where we solve that the square root of 16 is in fact 4, and it came outside of the radical. And then the last step would be just to rewrite your final answer. And of course that's referring to right here where we brought down the radical so that our final answer was 4 root 3. So there's a lot of steps here. We're going to keep practicing this. We're going to do another example problem. So let's take a look at number 2 on the worksheet that was assigned. Question number 2 says simplify the square root of 75. Well, we now know step 1 is to identify the largest perfect square that 75 is divisible by. So I'm going to jump back to this list here. I'm going to look at all of my perfect squares that are smaller than 75. So 64 is smaller than 75, and then all the way down. Well, 75 divided by 64 does not give us a whole number. It gives us a decimal. If I take 75 and divide it by 49, I'm still going to get a decimal value, not a whole number. If I take 75, divide by 36, it's still going to be a decimal. But if I take 75 and I divide it by 25, I finally get a whole number. And so we can use our calculator to see that. If I take 75, divide by 25, it is 3. So I know now that the square root of 75 can be written as, sorry, I can zoom in here too, maybe it will help us see a little bit better. The square root of 75 can be written as the square root of 25 times 3, because 25 times 3 gave us 75. So then I can just rewrite this again by separating out these terms underneath their own radical. So I've got the square root of 25 times the square root of 3. Once again, all of these are equivalent expressions. It's just 3 different ways to write the exact same information. The reason we write it this way is because I now have exactly what I'm looking for, which is a perfect square. The square root of 25 is a perfect square. It comes out to a whole number. If we remember from our list, the square root of 25 is 5. Because it is a whole number, we can now take it outside of the radical. The square root of 25 is 5. The square root of 3 is not a perfect square, and also is not divisible by any of the perfect squares. We can see that it falls between 1 and 4, and everything is divisible by 1, so that does not help us simplify. So then we're just going to go ahead and rewrite it. It's going to be the square root of 3.